Welcome you all. In this video we will see how we can generate and visualize a real exponential signal. As you see here, a real exponential signal can be indicated mathematically in both a continuous time and discrete time as follows. In continuous time it can be represented as x of t equal to e power at, and in a discrete time it is represented as x of n equal to a power n. So depending upon the A data, the signal may be exponentially increasing or exponentially decreasing. So whenever A is a positive number, then the signal is generally exponentially increasing. Whenever A is a negative number, then the signal is exponentially decreasing. Right, now let's see how we can generate the signal in a MATLAB. So I just open the new script. So as we always do, we have to first create a x-axis variable. So for that I just use a previous code, right, and I made a time axis data of -10 to +10 in a continuous time, and then samples from -10 to 10 for a discrete time, right. So let's rename this figure as real exponential signal, right. So I am going to make a real exponential signal in a continuous time and a discrete time in a single plot window. So for that I go with the subplot option. Okay, right, now okay, let's save this file. This is real exponential signal, right. So right now we have time data, right, that is a time vector. Now for each of the time I need to build a corresponding amplitude to make a exponential signal, that is a real exponential signal. So the mathematical expression for real exponential signal is e power a times of t, right. So in a MATLAB, to put a exponential function, we have a command called exp, which is nothing but e power, right. So let's take a magnitude of a signal as y1, as we always do, which is equal to exponential, which is exp, which is nothing but e power a times of t. So let's fix initially a is a positive number. For say example, let's keep a as 2. So 2 into t. So this is going to be a real exponentially increasing signal, right. Okay, now we made a time as well as corresponding amplitude. Now we go for making a plot. So plot t comma y1, right. So this is going to create a real exponential signal in a continuous time, right. So now we make a label and title for the plot, so which I copy from the previous program and I edit as per this program need. Okay, so x label time and y label amplitude, and title let's fix real exponential signal in a continuous time, right. Okay, so now we do the same thing in a discrete time. So first I declare the plot position using a subplot command. So I wish to see the real exponential signal in the second position of a plot window. So I keep 2 comma 1 comma 2. Then I just create a magnitude for each of the samples. So let's take the magnitude as y2, which is equal to exponential of a times of n. So let's keep a as 2 as we did for a continuous time. So 2 times of n, right. So this will create an amplitude. So now I go for a plot. So to make a discrete plot, we should use a stem command. Stem n comma y2, right? Now let's make a label, copy and paste. So x label is actually about sample, y label is amplitude, and title let's keep real exponential signal in a discrete time, right? Now just save this file and just run this to visualize the signal. Now as you see here, the signal is getting exponentially increased in a continuous time, and similarly in a discrete time you can see the signal is increasing linearly, right? Even if I compress the a, we can able to see the signal in a proper way. So instead of keeping a as 2, let's keep that a as 0.5. Here also keep a as 0.5. So save and run. Now you can see the signal is getting exponentially increasing. Now I just change this a to minus 0.5, and similarly here I just keep this as a minus 0.5. Now you run this, you can see now the signal is exponentially decreasing, right? So whenever a positive, we have seen that the real exponential signal is linearly increasing, exponentially increasing. Similarly, whenever we kept a as a negative, the real exponential signal is exponentially decaying, that is exponentially decreasing. Thank you.